Hello students, now let's discuss the chemistry questions of your NEET examination. So let's start with your question number 51. Here you can see that in question number 51 they are saying match list 1 with list 2. In list 1 they have given the monomers which are caprolactam, ethylene glycol and benzene 1,4 dicarboxylic acid, hexamethylene diamine and adipic acid, and phenol and formaldehyde. In list 2 they have given polymers which are bakelite, nylon 6,6, nylon 6 and terylene. So students, this is a knowledge based question in which you need to match the perfect monomer with the perfect polymer. Okay, these are the options that are given, that was given in the question paper. You can see that for caprolactam monomer we have a polymer nylon 6. For ethylene glycol and benzene 1,4 dicarboxylic acid we have terylene. For hexamethylene diamine and adipic acid we have nylon 6,6. For phenol and formaldehyde we have bakelite. So our correct answer will be option number 2. Okay. Now students, let's discuss question number 52, which says, which of the following is the correct statement? Al plus is more stable than iron plus, gallium plus is more stable than aluminium plus is more stable than gallium plus is more stable than indium plus. Okay students, so this is a question here where you can see that the elements are what? Boron, the family is boron, aluminium, gallium, indium, thallium. Okay, now they are saying that we have Al plus, we have Ga plus, we have iron plus. Okay, so we have Al plus, iron plus and Ga plus. Okay, fine. So here they are saying that which one will be more stable. So students, when you will observe this question, you will observe this option number 2 and 3. That option number 2 is gallium plus is more stable than aluminium plus. Option number 3 is aluminium plus is more stable than gallium plus. Okay, so it means that the answer must be from option number 2 and option number 3. Here the concept will be what? Inert pair effect. So you will see that inert pair effect take place into account due to what? Post screening shielding effect of DNF electrons. This effect is easily observed generally in p block elements where the stability of lower oxidation state increases down the group. So it means what? When we talk about the stability of lower oxidation state down the group, it means from boron towards thallium, the stability of lower oxidation state increases due to what? Inert pair effect. So from this concept we can say that gallium plus is more stable than aluminium plus. So because of this, our correct option will be option number 2. Students, now let us discuss question number 53, which says, which one of the following statements is true about the structure of CO3 2 minus ion? Out of 3 CO bonds, 2 are longer and 1 is shorter. It has 3 sigma and 3 pi bonds. All the 3 CO bonds are equal in length with a bond order in between 1 and 2. It can be explained by considering sp3 hybridization. So students, when I talk about CO3 2 minus ion, okay, each bond of CO will be equal due to resonance, okay, and each bond will have partial double bond character. Okay, that is why the bond order will be between 1 and 2 and each bond will be equal. So our option number 3 is correct. You can see here these are the resonating structure, and because of this option number 3 is correct. It means all 3 CO bonds are equal in length with a bond order in between 1 and 2, and concept here is what? Resonance. Students, let us discuss question number 54, which says, which one of the following electron in the ground state will have least amount of energy? An electron in 2p orbital of the carbon atom. Electron in 2p orbital of carbon atom. So here n will be 2. The electron of copper atom present in 4s orbital, n will be 4. The outermost electron of sodium atom, when I write the electronic configuration of sodium, it will be 1s2, 2s2, 2p6, 3s1. Outermost electron will be 3s1, so n equals to what? 3. The n electron in the hydrogen atom, n equals to 1. So the least value of n will be 1. That is why the electron, which one of the following electron in the ground state will have least amount of energy? It will be option number 4, because the value of n will be minimum in option number 4. That is why it will have minimum energy, and option number 4 will be our answer. Okay, so the concept is this, which we people have read, that the energy of 1s is least, then 2s, then 2p, then 3s, 3p, 4s, 3d, 4p, 5s. Okay, So this will be our concept, and because of this, the answer will be option number 4, which is an electron in the hydrogen atom. So students, let us discuss question number 55, which says, which of the following is not correct? Okay, mark this, not correct, about postulates of kinetic molecular theory of gases. Let's see option number 1. Volume of the gas is due to the large number of molecules of the gas. So this is what? Not correct. Our answer will be option number 1. Why? Because volume of the gas is what? Volume of container, right? It is not because of the large number of molecules of the gas. So that is why this postulate is not correct. Okay. Now the concept here will be gases consist of large number of identical particles that are so small and so far apart on the average that the actual volume of the molecule is negligible in comparison to the empty space between them. They are considered as point masses. There is no force of attraction between the particles of gas at ordinary temperature and pressure. The support for this assumption comes from the fact that gases expand and occupy all the space available to them. And we know that volume of gas will be the volume of container. Okay. So our option number 1, which is volume of the gas is due to the large number of molecules of the gas. This is not correct, and this will be our answer. So students, let us discuss question number 56, which says, the work done when 1 mole of gas expand reversibly and isothermally from pressure of 5 atm to 1 atm at 300 Kelvin is given. Log 5 equals to this and R equals to this. Okay. So it's underlined. 1 mole is given, expands reversibly and isothermally, pressure of 5 atm to 1 atm at 300 Kelvin. Okay. Log 5 and R is given. So students, the formula that we people are going to use here will be minus 2.303 nRT log P1 by P2, P1 divided by P2. Okay. So from the question we have read that the value of N will be 1 mole. Okay. R, what was the value of R? 8.314 joule per Kelvin per mole. 8.314 joule per Kelvin per mole. For temperature, it is what? 300 Kelvin. And we will multiply log. P1 is 5 atm and P2 is what? 1 atm. Okay. Now you can see here mole and mole get cancelled. Kelvin and Kelvin get cancelled. This atm get cancelled. Okay. So it is minus 2.303 into 8.314 into 300 into log 5, and the value of log 5 is given, which is 0.6989. Okay. So I will write 2.303 into 8.314 into 300 into what? 0.6989. 0.6989. So the answer comes out to be what? Option number 3, which is minus 4014.6. So option number 3 will be our correct option for this question. Students, let us discuss question number 57, which says LiF is sparingly soluble in water because it has small electronegativity, high lattice enthalpy, low hydration enthalpy, partial covalent character. So from this question we need to say that why LiF is sparingly soluble in water. LiF is sparingly soluble in water because of its high lattice enthalpy. So the hydration enthalpy will be lower in comparison to lattice enthalpy. It means high lattice enthalpy. That is why LiF is sparingly soluble in water. So option number 2 will be correct. You can see here that due to high lattice enthalpy. So we can say that lattice enthalpy is more than hydration enthalpy. Okay. So students, let us discuss question number 58, which says, what is the correct order for boiling points of the following compounds? So here they are talking about nitrogen family. It is nitrogen, phosphorus, arsenic, antimony, bismuth. Okay. Now students, when we go top to bottom, the atomic mass will increase, boiling point will increase, but here you can see they are talking about hydrides, right? So they are talking about hydrides, and when I talk about NH3, it will have what? Hydrogen bonding. Okay, so the order, which is generally the order is top to bottom, boiling point increases, that order will not be followed, and there will be a exception because of the hydrogen bonding which is present in NH3 molecule. So our option number 1 will be the correct, that is boiling point of BiH3, then SbH3, then NH3, then ASH3, and then PH3, and the reason is hydrogen bonding present in NH3. So due to hydrogen bonding in ammonia, the order will be BiH3, SbH3, NH3, ASH3, and PH3. Okay, so our correct answer will be option number 1. Students, now let us discuss question number 59, which says, a ferromagnetic substance become a permanent magnet when it is placed in a magnetic field because, number 1, domains are not affected by magnetic field. So in this question they are asking that ferromagnetic substance becomes a permanent magnet. Okay, so they are talking about permanent magnet, and when it is placed in magnetic field, because domains are not affected by magnetic field, domains are affected, so this is wrong. Domains get randomly oriented? No, domains are not randomly oriented. All the domains get oriented in the direction of magnetic field. Yes. Okay, let's read the option number 4 also. All the domains get oriented in the direction opposite to the direction of magnetic field. This is wrong. So option number 3 will be the correct option. Knowledge based question. You can see that when the substance is placed in a magnetic field, all the domains get oriented in the direction of the magnetic field, and a strong magnetic effect is pronounced. You can see that or are arranged, right? The ordering of domain persists even when the magnetic field is removed, and the ferromagnetic substance becomes a permanent magnet. So you can see that all the domains get oriented in the direction of magnetic field. So you can see that the orientation, now our correct option is what? All the domains get oriented in the direction of magnetic field. So option number 3 is our correct answer. Students, now let us discuss question number 60, which says, which one is not a D sugar? Okay, so we have 4 options, option number 1, option number 2, option number 3, and option number 4. Now here students, we will see that which one is not a D sugar. So for D sugar, the OH group must be present on the right hand side. Of the bottommost carbon which is asymmetrical, the OH group must be present on the right hand side. So here you can see that H group is present on right hand side. So this is not a D group, this is not a D sugar. Okay, talking about 2, this is present, so yes, this is OH present, yes, this is OH present, yes, this is asymmetrical carbon. You can see last asymmetrical carbon, H, OH, this and this also H, CH2OH, OH in this group, OH, H, CH2OH in this group, OH, H, CH2OH in this group. Okay, and H is present on the right side, that is why this is not a D sugar. So option number 1 will be our correct option. Okay, so option number 1 will be our correct option. Why? Because this is the asymmetrical carbon and H is present on the right side. So students, now let us start with question number 61, which says, match list 1 with list 2. List 1 we have amines, N-methyl methenamine, second ammonia, C-N-methyl aniline, and fourth benzenamine, and pKb values 9.30, 9.38, 4.75 and 3.27. So we need to match the correct values of pKb. So these are the options. So what will be the concept here? That if pKb value is more, basic strength will be less. Okay, now when I talk about N-methyl methenamine, okay, it will be what? This is one, N-methyl methenamine. When I talk about ammonia, it will be NH3. When I talk about N-methyl aniline, it will be this is N-methyl aniline. When I talk about benzenamine, it will be what? This will be what? Benzenamine. So students, you can see from here, we know the concept that aromatic amines are less basic in comparison to aliphatic amine, and here you can see that this will be the most basic one. That is why you can see pKb value is least 3.27, then ammonia 4.75, And if I compare N-methyl aniline and benzenamine, here you can see the CH3 group. Okay, that is why the value donating group, that is why the pKb value 9.30 and here 9.38. So this will be our what? Correct pKb values, and our option will be option number A. Students, now let us discuss question number 62, which says the number of bridging carbonyl groups in CO2-CO8 and Mn2-CO10 respectively are. So we need to understand this question with the help of structure. So you can see that they are talking about the bridging carbonyl group. So in CO2-CO8, you can see that 2 and in Mn 0, right? So the answer will be 2 and 0, option number 4. And we can understand this with these structures. Now students, now let us talk about question number 63, which says match list 1 with list 2. In list 1, element which exhibit +3 oxidation state only, elements which exhibit more number of oxidation state, elements which is reducing agent in its +2 oxidation state, element which is not considered as transition element. So students, in the list 2 we have Mn, zinc, scandium and chromium. So when I talk about element which is not considered as transition element, it is zinc. Why? Because when I write the electronic configuration of zinc, it will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and the common oxidation state Zn plus 2, it will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s0, 3d10. So when we talk about zinc, you can see that fulfilled orbitals, and in Zn2 plus also it is fulfilled orbitals. Okay, so because of this reason, zinc is not considered as what? Transition element. This is pseudo transition element. So for our D option, it will be what? Zinc. So for D it will be 2. So for D it will be 2. That means option number 1 and option number 2 will be discarded. Okay. Now talking about elements which exhibit +3 oxidation state only. Okay. So element which exhibit +3 oxidation state will be scandium. And why? Because when I write the electronic configuration of scandium, it will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. And in scandium 3 plus, it will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s0, 3d0. Okay, so scandium has +3 oxidation state. Okay, so for option number, for A, it will be 3. So in both the option we have A3. Now either B1C4 or B4C1. Okay, so let's talk about B, element which exhibit more number of oxidation state. So when I write the electronic configuration of manganese, it is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d5, right? So this manganese can exhibit oxidation state from +2 to +7. So it has many oxidation state. So for B, it is first. So for B, it will be first. This is not our option. So answer will be option number 3. But let's see C also. Element which is a reducing agent. Okay, reducing agent in its +2 oxidation state. Reducing agent means what? Reduces other, oxidizes itself. Now they are saying that reducing agent in +2 oxidation state. Okay, so when I talk about this chromium, and when we write the electronic configuration of chromium, it will be what? 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d5. Okay, now in chromium in +2, it will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s0, 3d4. Now when it goes from +2 to +3, okay, 1s2, 2s2, 2p6, 3s2, 3p6, 4s0, 3D3. And when we write it in terms of T2G and EG, it will be T2G3, EG0. It will be stable, okay, half filled. That is why it is what? A better reducing agent in +2 oxidation state, because it wants to go from +2 to reducing agent. It reduces other oxidizes itself from +2 to +3 because of this stable configuration. So for C we have 4. So you can see that for C we have 4. That is why our option number 3 will be correct option. Okay. Now students, now let us discuss question number 64, which says, given below are two statements. Statement 1, the product of reaction of phenol with bromine depends on the nature of solvent. Statement 2, reaction of phenol with bromine in CaCl3 gives mono substituted bromo derivative, whereas reaction of phenol with bromine water yields tri-substituted bromo derivatives of phenol. So students, both these statements are true. You can see here the concept that when the reaction is carried out in a solvent of low polarity such as CHCl3 and CS2, at low temperature mono-bromophenols are formed. So you can see that when the solvent is CHCl3 and CS2, mono-bromophenols are formed, and when it is what? Treated with bromine water, okay, it is 2,4,6 tribromophenol. So you can understand that the product of reaction of phenol with bromine is depending on the nature of solvent. So this is correct. Now reaction of phenol with bromine in CaCl3 gives mono substituted bromo derivative. You can see here mono substituted bromo derivative, right? Whereas reaction of phenol with bromine water yields tri-substituted bromo derivative of phenol 2,4,6 tribromophenol. You can see here. So from this we can understand that statement 1 and statement 2 both are correct, and our option number 2 will be the correct answer, which is statement 1 and statement 2 both are correct. Now students, let us discuss question number 65, which says, match list 1 with list 2. List 1 is example of colloidal system, which is insecticide spray, whipped cream, paint and hair cream. List 2 has dispersion medium liquid, dispersion phase solid, dispersion medium gas, dispersion phase liquid, dispersion medium liquid, dispersed phase liquid, dispersion medium liquid and dispersed phase gas. Again, this is a knowledge based question. We need to, this is the table which is given in NCERT. You can see the examples, and from that example the question is asked. So you can see that when I talk about insecticide spray, okay, here you can see when we are talking about insecticide spray, our dispersed phase is what? Liquid, and dispersion medium is gas. And when we are talking about whipped cream, you can see here in this table that when we are talking about whipped cream, the dispersed phase is gas and dispersion medium is liquid. Okay. When we are talking about paint, you can see in the example that when we are talking about what? Paints, the dispersed phase is solid and the dispersion medium is liquid. Okay. And when we are talking about hair cream, so here you can see that when we are talking about hair cream, the dispersed phase is what? Liquid, and the dispersion medium is liquid. So students, you can see that this question is directly from the NCERT the table, okay, knowledge based. You need to learn that table and you can easily answer this question. Now, what will be our correct option? Option number 4, okay. Students, let us discuss question number 66, which says, the solubility product of BSO4 in water is 1.5 into 10 to the power -9. The molar solubility of BSO4 in 0.1 molar solution of BaNO3 whole twice. So here the concept will be common ion effect. So first let's talk about BSO4. So when I talk about BSO4, it will be what? Ba plus 2 and SO4 2 minus. Solubility will be S and S. Okay. Now here you can see that we have a BaNO3 whole twice also. Okay. So when we have BaNO3 whole twice, it will be Ba plus 2 and NO3 2 minus, NO3 minus, not 2 minus. Okay. So here will be 2. So initially it was 0.1. Now it will become 0.1. Now this is for our concern because this is the common ion. Okay. Now because of this common ion, the solubility from S changes to S dash. And now when I write the solubility product, okay, solubility product of BSO4, it will be concentration of Ba plus 2, solubility of Ba plus 2 and SO4 2 minus, right? So it will be S dash plus 0.1. It will be S dash plus 0.1, and for SO4 2 minus it will be S dash. Now students, S dash plus 0.1 will be approximately equals to 0.1. Why? Because S dash is very less than 0.1. Okay. Now the value of Ksp is given, which is 1.5 into 10 raised to the power minus 9. 1.5 into 10 raised to the power minus 9. Now if I want to calculate S dash, so it will be what? S dash will be 1.5 into 10 raised to the power minus 9 divided by 0.1, which is 1.5 into 10 raised to the power minus 8. Okay. So students, our answer is option number 2, which is 1.5 into 10 raised to the power minus 8 molar. This will be our answer. Now students, let us discuss question number 67, which says the correct order of acidic strength of the following molecule. You can see we have alcohol, we have water, we have acid, and we have phenol. So students, from this what we people can understand that this acid will have maximum acidic strength. So option number 1 is gone. Okay. Now if I talk about phenol, water and alcohol, phenol is the most acidic. So yes, this is also gone. Now between water and alcohol, water is more acidic. Okay, so option number 2 is correct and option number 3 is incorrect. Now the reason is, our answer will be option number 2. Now why? What is the reason? Let's see. That when I compare alcohol with water, we will say that alcohols are weaker acid than water. Why? Because you can see this is base, this is alkoxide, this is what? Water molecule. This alkoxide will take H from water molecule and it will become OH minus. So from this what you can say that this reaction shows that water is a better proton donor, that is stronger acid than alcohol. Also in the above reaction, we note that the alkoxide ion, this is the alkoxide ion, is a better proton acceptor than hydroxide ion, which suggests that the alkoxides are stronger bases. So from this we can understand that water is more acidic in compared to alcohol. Now in the second case, you can see that this is alkoxide ion and this will be phenoxide ion, and phenoxide ion will be more stable. It will be more stable. Okay, due to what? Due to resonance. This phenoxide ion will be more stable. Okay, so that is why phenol is more acidic in compared to alcohol, and when we compare alcohol and water, water is more acidic. So that is why you can see that alcohol, then water, then phenol, then CH3COOH. So our option number 2 is correct. Students, now let us discuss question number 68, which says, which one of the following is the correct order of decreasing bond enthalpies for the given species? N2O2, O2 2 minus and O2 minus. So now let's first write the electronic configuration. The answer will be option 2, but let's write the electronic configuration. For N2, it will be sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, pi 2px, pi 2py, 1 1 2 2. So it will be 2 4 6 8 10 12, sigma 2pz 2 14. Okay. Now when we calculate the bond order, the formula for bond order, that we people are going to use is half Nb minus Na, Nb for bonding molecular orbital and Na for anti-bonding. So here bond order will be half. Let's count Nb 2, 4, 6, 8, 10, Na 2, 4. So 6 by 2, bond order is 3. Okay, now let's write the electronic configuration of O2. It is what? Sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. Okay, now sigma 2pz2, pi 2px, pi 2py, 10, 11, 12, 13, 14, pi star 2px, pi star 2py, 15, 16. Now when I find the bond order, okay, it will be half Nb minus Na. So let's count Nb 2, 4, 6, 8, 10. Let's count Na, 2, 4, 5, 6. So bond order comes out to be 2. Okay. Now when I talk about O2 minus, this will be same. Okay. In O2 minus, till here everything will be same. Till here everything will be same. Okay. So I am denoting it as K. Okay. And now the change will be what? Sigma star 2px 2 sigma star 2py 1. Why? Because in O2 minus there is addition of one electron. So when I calculate the bond order, you can see the new electron is added into anti-bonding. So it will be half. NB will be same 10 minus Na, it will become 7. So it will be 3 by 2, which is 1.5. Okay. Now this same goes for O2 2 minus. Now you can see that till here the electronic configuration will be same, right? Now one more electron get added into pi star. One more electron gets added into pi star. So bond order becomes what? Half 10 minus 8, which is 1. Now student, the concept here is what? If bond order increases, bond strength increases. Okay. So you can see correct order decreasing, bond enthalpy. Okay. So bond order increases, bond strength increases, bond enthalpy will also increase. So you can see bond order is maximum for N2. So that is why the bond enthalpy will be maximum for N2. So you can see these two options get discarded, and after N2 it will be O2. Okay. After N2 it will be O2, then O2 minus and O2 2 minus. So you can see O2 minus and O2 minus, option number 2 will be correct. Okay students. So students, now discuss question number 69, which says the correct reaction among the following is. Okay. So let's see the first reaction. Bromobenzene, Na triether. Yes, this is correct. This is what? Fitting reaction. So our answer will be option number 1. You can see that 2 benzene with the halogen in the presence of sodium triether, we get diphenyl. Okay. So our option number 1 will be correct, which is the fitting reaction. So students, now let us discuss question number 70, which says statement 1, aldehyde and ketone having at least one alpha hydrogen undergo aldol condensation in the presence of dilute alkylase catalyst. Yes, this statement is true, because when we talk about what? Aldol condensation have at least one alpha hydrogen and in the presence of dilute alkylase catalyst. Okay, so statement number 1 is correct. Talking about statement number 2, when aldol condensation is carried out between the two different aldehyde, it is called cross aldol condensation. Yes, two different aldehyde, cross aldol. Yes, ketone do not give this reaction. No, this is wrong. Okay, this is wrong. So ketone can give this reaction when have alpha hydrogen in the presence of dilute alkali. So statement 2 is wrong. Why statement 2 is wrong? Because here it is written ketone do not give this reaction. Ketone can give this reaction. Okay, when ketone will have alpha hydrogen in the presence of dilute alkali. Okay, so that is why statement number 2 is wrong. So statement 1 was our correct, statement 2 is wrong. So option number 4 will be the correct answer.
Okay students, let us see the next question. Question number 71. What it reads, students? It says that the incorrect statement among the following regarding food preservatives is. When you study the chapter chemistry in everyday life, in that you study about food preservatives. Right students? In this topic of food preservatives, you have to identify which of the following statements is incorrect or false statements regarding food preservatives. The first statement says what? Antioxidants are used in wine are sulfur dioxide and sulfides. This is a knowledge-based question, right students? We know that the antioxidants that are used in wine are SO2 and sulfides. So that's a true statement. So statement number 1 is a true statement. Regarding the food preservatives, especially talking about antioxidants. Second statement says that antioxidants help in preserving the food longer. Yes, that is what is the function of antioxidants. The function of antioxidants is to preserve the food longer. So statement number 2 is also correct, students. Statement number 3 says that antioxidants react with oxygen with a slower rate than food. if antioxidants will react with oxygen at a slower rate than that of food, students, then definitely the spoilage of food will take place. We cannot preserve food, or antioxidants cannot be used as food preservative. So this is the contradictory statement of statement number 2. So the incorrect statement is your statement number 3. Yes? And statement number 4, sorbic acid and propanoic acid are good food preservatives, is a true statement because that is an example of food preservatives. The chemicals that are used as food preservatives are examples. Sorbic acid and propanoic acid are some of the examples, right, students? So we can say that your correct option is option number 3, and that is an incorrect statement, but the correct answer is option number 3. That is question number 72. Question number 72 reads that 1 mole of sugar is dissolved in 3 moles of water at 298 Kelvin. The relative lowering of vapor pressure is, we know that relative lowering vapor pressure is a colligative property. It's a question of standard 12th. Yes, students? Now, you know that what is the relation between relative lowering in vapor pressure and mole fraction? We know that relative lowering in vapor pressure is equal to mole fraction of solute. You know the number of moles of solute sugar is 1 mole given to you. Number of moles of your solvent water is 3 moles. You can find out the mole fraction of solute. And whatever is the mole fraction of the solute, that will be equal to the relative lowering of vapor pressure. So let's do that calculation, students. Okay. Relative lowering in vapor pressure. Okay. Relative lowering in vapor pressure is equal to mole fraction of solute. And you know that how to find out the mole fraction of solute. Mole fraction of solute will be equal to number of moles of solute, that is number of moles of sugar given to you as 1 mole, divided by number of moles of solute plus number of moles of solvent. Therefore, mole fraction of solute will be equal to, that is number of moles of solute is 1 mole divided by total number of moles of solute plus solvent, that is 1 plus 3, that is equal to 4. Simple. 1 divided by 4 will come as 0.25. Yes, students. So your correct option is option number 4. Right, students? Simple numerical. Yes, simple numerical and simple calculation gives you the correct answer and you get the full marks. Hope that most of you might have got this answer as the correct option, right? Fine, students. The next question is a match the following type of question, students. Question number 73. You have given list 1 and list 2. In list 1, you have the elements, oxygen, carbon, boron and nitrogen, labeled as A, B, C, D. And list 2, you have the atomic radii of these elements given to you in picometer, that is labeled as 1, 2, 3, 4. Now, you have to find out from the choices which is the correct matching. That means you have to do the correct matching with respect to atomic radii and the elements given to you, oxygen, carbon, boron and nitrogen. Now, we know that oxygen, carbon, boron and nitrogen are the elements of the second row of the periodic table. Yes, which are the other elements present? Lithium, beryllium, boron, carbon. Nitrogen, oxygen and fluorine are the total elements of the second row. We know that as we move from left to right in a period, the atomic radius goes on decreasing. Why the atomic radius goes on decreasing, that also you know, because there is an increase in nuclear charge, or effective nuclear charge or force of attraction increases, the atomic radius decreases. So what will be the general trend for the elements? From the given elements, if I consider all the elements, it will be is greater than beryllium, is greater than boron, is greater than carbon, is greater than nitrogen, is greater than oxygen. That means if you consider, you have to consider only boron, carbon, nitrogen and oxygen. That means oxygen is the least. Oxygen is the least. Which is the least value? Least value of oxygen is, the least value of oxygen will correspond to 66 picometers. So A is matching with 3. Then is nitrogen. Nitrogen will be 74. D is matching with 2. Yes. Then is carbon. Okay. Carbon will be 77. B is matching with 4. And then you have boron, which is having the highest, will be 1. Right, students? So you can match the choice and see. A is 3, B is 4. Yes? And then you have C is 1 and D is 2. So your correct option is option 3. Right, students? Simple application based question. This type of questions we have solved from our modules of NEET also. Right, students? So this is straightforward question, application based question from your periodic table. Okay. The next question, number 74, is again match the following type of question. You have been given list 1 and list 2. In list 1, you have the organic compounds given in the bond line formula. Okay. To make the question little challenging. Okay. Just to make the question little challenging, they have written the compounds in the bond line formula. Yes, students. And in list 2, we have the boiling points given to you. Now you have to choose the correct answer from the options given below. Now these are basically hydrocarbons. If you look at them, they are all hydrocarbons. They are all your alkanes. They are straight chain and branch chain alkanes. What is the relationship between boiling point and the organic compound? You know that. Boiling point increases with increase in molar mass. That is, boiling point increases with the increase in the number of carbon atoms. As the number of carbon atoms increases in the straight chain, the boiling point increases. Boiling point decreases with branching, students. When boiling point decreases with branching, yes, so branched alkanes will have lower boiling points and straight chain alkanes will have higher boiling points. Okay, let us look at the structure. If you look at the structure very carefully, in structure number A, you have how many carbons? In structure number A, you have 1, 2, 3, 4 and 5 carbons. That means a straight chain alkane containing 5 carbon atoms. In structure number B, you have 1, 2, 3, 4, 5 and 6 carbons. So now you can tell that number of carbons in A and B is 5 and 6 respectively. Number of carbon atoms increases, the boiling point increases. So you can say that B will have a greater boiling point than that of A. Boiling point of B will be greater than A. Now we consider between C and B. Between C and B, if you see that, students, there is one branching in C. Total carbons in C are how many? There are 5 carbons, but there is one branching. And if there is a branching, the boiling point decreases. So therefore, you can conclude the boiling point of C is less than B. Okay. Boiling point of B was greater than A, but boiling point of C is less than B. Boiling point of C is less than B. In option D, there are 2 branching, students. There are 2 branchings. Total carbons are 5, but there are 2 branchings. So boiling point decreases with increase in branching. So D, when it has 2 branching, should have the least boiling point. So when D should have the least boiling point, match it with the choices given. So D, which is the least boiling point from the choices. So D will get matched with second, 282.5. Then next will be C. Next will be C, that is 1. Okay. Then comes B will be greater than A, or A will be less than B. So when A will be less than B, that means A will go to 3 and B will go to 4. Okay, so now which is the correct option? You can check the option 2. A is 3, B is 4, yes, C is 1 and D is 2. Right, students? So this is the correct option. That is option number 2 is the correct matching for the boiling points and the respective hydrocarbons. Yes, I hope you have understood this, that students. Increase in boiling point takes place when there is increase in number of carbon atoms or molar mass. But if branching comes, the boiling point decreases. The basic concept of your 11th standard. Okay, students. The next question is question number 75. It reads that alkali metals, though white, impart a characteristic color to the flame because of. alkali metals, though they are white, they are imparting a characteristic color. They are forming a characteristic color to the flame because of. Which of the correct options is right? Option 1 says oxidation of metal in the presence of flame. Option 2 says excitation of valence electrons. Option 3 says gain of electrons. And option 4 says excitation and coming back of valence electrons to the original level. What happens is, when alkali metals, they will impart a characteristic color when they are exposed to flame. That means when they come in contact with flame, the heat of the flame will excite the electrons from the valence shell of the alkali metals. And they are salts. So when the excitation of the electron takes place, when this excited electrons come back to the ground state, when it comes back to the ground state, it will emit the absorbed energy of light from the visible region. So it will emit the light from the visible region once it comes to the ground state. So now after this explanation, students, you can match the correct option. Yes, it is excitation and coming back of valence electrons to the original level or the ground state. So according to the concept, students, it is option 4 is the right answer. Yes, students? I hope this is explained to you properly. You might go for excitation of valence electrons. Yes, excitation of valence electrons takes place. But not only excitation of valence electrons. Those excited valence electrons, when they come back to the ground state, they emit the color from the absorbed radiation of light. They emit the color from the visible region. So this option number 2 is just to trick you, students. You have to be very careful while selecting the option. And I hope most of you might have marked option 4 as the right answer. The next question, number 76. It reads that, identify the set from the following which all species can exhibit disproportionation reactions. You have been given species to you, students, in the choices. You have to identify which set of species will exhibit disproportionation reaction. What is a disproportionation reaction? A disproportionation reaction is a reaction in which the species undergoes both oxidation and reduction. Those species will undergo oxidation and reduction if there is increase in oxidation number as well as decrease in oxidation number shown by those species. Right, students? So now you have to identify first, students. What will you do? First, try to identify those species which will not undergo disproportionation reaction. That means they will either undergo only oxidation or only reduction. Okay. So one hint from this question I can give you, student, is that if you look at the species, ClO4 minus. ClO4 minus is the species in which the oxidation state of chlorine, if you calculate the oxidation number of chlorine, you know how to do the calculation of oxidation number of chlorine in a given species. Oxidation number of oxygen is -2. There are 4. So -2 into 4 is -8. Sum is equal to -1. So chlorine will be equal to -8 goes, that's it, becomes +8. -1 becomes +7. So oxidation state of chlorine over here is +7. Now you know that chlorine can exhibit variable oxidation states. Common oxidation state shown by halogen is -1. Along with -1 oxidation state, chlorine will also show +1, +3, +5 and +7. So maximum oxidation state shown by chlorine is +7 in its compound. So it cannot increase its oxidation number further, but it can decrease its oxidation number. That means it can only undergo what? It can only undergo oxidation or reduction. There can be increase in oxidation number. Increase in oxidation number is oxidation. It cannot undergo oxidation, students, because there is no increase in oxidation number. It can only undergo reduction because there is decrease in oxidation number can take place. Right, students? So therefore, this species will not show disproportionation reaction. So if this species does not show disproportionation reaction, in which of the choices, students, this compound is not there? If you look at choice 2, 3 and 4, in choice 2, 3 and 4, you have ClO4 minus. That means that set will not undergo disproportionation reaction. So there is only one choice in which ClO4 minus is not there, and that is option 1. So which is the correct option, students? Option 1 is your right answer. Right, students? We have seen that ClO4 minus is not there in option 1, whereas you can check for rest of the species. They will exhibit oxidation numbers which can be increased or decreased. Okay, hence option 1 is the correct option. Okay, the next question reads that for the reaction 2A goes to B, the rate expression is given to you. Rate of the reaction is equal to K into concentration of A raised to 2. Now, the question asks is that if the concentration of the reactant is doubled, then which of the following choices are correct? Choice 1 says if the concentration of the reactant is doubled, choice A says that rate of the reaction will be doubled. Choice B says that rate constant will remain unchanged. However, rate of reaction is directly proportional to the rate constant. Option C says rate constant will change since rate of reaction and rate constant are directly proportional to each other. And option D says rate of the reaction will increase by 4 times. Let's see, students, which options A, B, C, D are true or which are incorrect. Okay, students. So now from the rate expression, we know that the rate of the reaction is given to you as rate of the reaction K into concentration of A raised to 2. If the concentration of the reactant is doubled, so what will be the new rate of the reaction? New rate of the reaction will be equal to K into concentration of A is doubled, so 2 raised to 2. So rate of the reaction will be equal to K, that is concentration is doubled. What will happen? The rate of the reaction will increase how many times? The rate of the reaction will increase 4 times. That is proved by that, okay? Rate of the reaction will increase 4 times. So we can say that out of this choice, rate of the reaction will increase 4 times. So we have proved that rate of the reaction will increase by 4 times. That is, D is right. Now look at the choices, students. Start to eliminate from the choices, okay? In choice 2 you have D, and in choice 3 also you have D. But in A and in choice 1 and 4, students, you don't have the option D. So we can say that you can eliminate option 1 and option 4. You can be eliminated, right, students? That can be eliminated. Now you have to decide between second and third. So in choice 2, there is, along with D, you have option B as correct. So let us see. Rate of the reaction will be doubled is false. We have seen that the rate of the reaction will increase 4 times. So A is false again. So A is not a correct statement. And A is there in option 1, so it is removed. A is there in option 4, it is removed. B says what? Rate constant will remain unchanged. However, rate of the reaction is directly proportional to the rate constant. We know that rate of the reaction is directly proportional to rate constant. But rate constant is independent of concentration. Rate constant is independent of concentration. It does not change with concentration. We know that rate constant is only temperature dependent and independent of concentration. So option B, rate constant will remain unchanged, is the correct option. So which are the correct options? That is option B and option D are correct. So we can conclude that second option is the right answer. Yes, students? Yes, this is a question from your chemical kinetics. We have solved similar questions from our modules also. Okay, this is a module question. Fine, students? Okay, the next question reads that, again, it's a matching type of question. Okay, this year in chemistry, the questions of matching type are given many, right? And they are simple also. In list 1 and list 2, you have the mixture of substances and you have the method of purification or separation. Yes, students? Now here you have option A says that list 1 you have A, separation of aniline and water distillation mixture. How will you separate a mixture of aniline and water? We know that aniline and water are immiscible solvents or immiscible liquids. Yes, from your knowledge based question you know that aniline and water can be separated by steam distillation process. Okay, so here you can match, you can say that aniline and water mixture can be separated by steam distillation. Why you use steam distillation? Because this is an insoluble mixture. Aniline is a volatile liquid, so it will evaporate on exposure to steam. So under steam distillation it will evaporate, so you can separate aniline from water by steam distillation. Next, separation of aniline and chloroform mixture. Now separation of aniline and chloroform mixture. This mixture can be separated by using simple distillation process. Why simple distillation? Because the difference in the boiling point is very large. When the difference in the boiling point is very large, we use simple distillation or distillation process. So you can say that separation of aniline and chloroform mixture can be done by distillation process. Next is separation of glycerol from spent Li. Now you have only two options remaining. If you are not sure about option C, I think so option D will make it sure for you. Okay. So first let us see what is the correct method of separation or purification used by option D. Separation of different fractions of crude oil. We know that different fractions of crude oil can be separated by fractional distillation method. Yes, students. So here we will use option D, will go with 1. Therefore, what remains is separation of glycerol from spent Li is given by distillation under reduced pressure. Yes, students. So when you match this correctly, you can verify your answer, students. It is option 3 because A is 4, B is 3, C is 2 and D is 1. So option 3 is the correct option. This is a knowledge-based question, students. Yes, from your 11th standard portion. The next question reads that, okay, again it's a matching type of question number 79. You have been given list 1 and list 2. In list 1, you have the volume of oxygen at STP, that is 4.48 liters of oxygen at STP. Then you have option B says 12.02 to 10 raised to 22 molecules of water. C says 96 grams of oxygen and D says 88 grams of carbon dioxide. You have to match with number of moles, molecules, weight and liters on the right hand side, students. Yes, students. So for this, you will have to solve it, students. First, let us see. When I take 4.48 liters of oxygen at STP, okay, 4.48 liters of oxygen at STP. So what I'll do is, I will find out the number of moles for this. So when I find out the number of moles for this, number of moles is equal to what? Number of moles is equal to, we know that is, but number of moles we have to find out in terms of volume. What is the relation for number of moles in terms of volume? Number of moles is equal to given volume upon 22.4 liters. So when you take 4.48 liters upon 22.4, so that will come as 0.2 moles. But students, immediately don't conclude that option A is 0.2 moles. That's what you will do, students. Here there is a trick that is played over here. This 0.2 moles of oxygen at STP corresponding to option A is then converted in terms of grams. Okay, this 0.2 moles of oxygen will correspond to how many grams? You know that 1 mole of oxygen will be equal to 32 grams of oxygen. That is molar mass of oxygen. So 0.2 moles will correspond to 6.4 grams. So therefore option A is going with option 3, students. Later on I'll explain to you why you're not concluding that A is equal to option 1. A is equal to option 3. I proved it to you because 0.2 moles is corresponding to 6.4 grams, converting moles in terms of grams. So here you can say that option A is corresponding to 6.4 grams. Next, 12.022 into 10 raised to 22 molecules of water. Okay, this 12.022 into 10 raised to 22 molecules of water, students, this will correspond to 0.2 moles. Otherwise, if you match A with 0.2 moles, B will not be able to be matched only, students. Okay, because the number of choices in list 1 and list 2 are same. So here you can check that 12.02 to 10 raised to 22 molecules of water, number of moles is equal to given number of molecules upon Avogadro's number. Given number of molecules is 12.02 to 10 raised to 22 molecules divided by Avogadro's number, 6.022 into 10 raised to 23. So 10 raised to 23 goes up, makes it 10 raised to minus 23. 12 divided by 6 is 2. So it comes 2 into 10 raised to minus 1 and 2 into 10 raised to minus 1 is 0.2. Yes, 2 into 10 raised to minus 1 is 0.2. So therefore, A is not matching with 1, but which is matching? B is matching with 1. Yes, students? Clear? Okay. Now you have to match the remaining two. 96 grams of oxygen. Will it correspond to 67.2 liters of STP, or will it correspond to 12.044 10 raised to 23 molecules? Yes, students, let us check. So, 96 grams of oxygen. You have to convert this. Let us convert in terms of volume. What is the relation between? We know that number of moles is equal to weight upon molecular weight, and number of moles is equal to given volume upon 22.4 liters. So, let's take the interrelationship. When you take the interrelationship, students, the interrelationship will be, that is 96 grams of oxygen. I will do it here, students, for you. That is when you consider weight upon molecular weight is equal to given volume upon 22.4. So, 96 grams upon molar mass of oxygen, 32 grams, which is equal to given volume you have to find out upon 22.4 liters. So, this will go 1 times, this will go 3 times. Will be equal to 3 into 22.4. That is coming as, yes, students, you can check this on the backslide. When you go to the backslide, students, you can see that it will match with 67.2 liters. So, 96 grams of oxygen corresponds to 67.2. What remains is 88 grams of carbon dioxide. You can find out, you can convert this. How will you convert this? Weight upon molecular weight is equal to number of molecules upon Avogadro's number of molecules. From that, you can find out the number of molecules and you can get this as the correct option. Right, students? So, which is the option that is matching? Option 1. A is 3, B is 1, C is 4 and D is 2. So, one trick was here, students. One trick to confuse you, that option A or B is equal to 1 of the list 2 or not. And that I've just proved it to you. So, which is the correct option? I hope most of you have not got tricked with this question. Okay. The next question is question number 80. Again, matching type of question. List 1 and list 2 is given to you. The commercial name of the compounds are given to you and chemical name of the compound is given to you. You have to match the commercial name with the chemical name. Now, if you look at the commercial names, you have Escalgon, you have Permutate, you have soap and washing soda. So, soap and washing soda are easier to be matched first because you study them from the school level. Right, students? So, we know that washing soda is equal to sodium carbonate and soap is equal to sodium stearate. So, that means D is equal to 2 and C is equal to 4. So, D is equal to 2 and C is equal to 4 is in which choices? There is only one choice which is showing that D is equal to 2 and C is equal to 4. Without matching the other, you can go or opt for option 1 without wasting time. But still, if you want to confirm, okay, then you know that permutate is your sodium aluminium silicate hydrate. That means permutate is option 1. And then option A corresponds 3. Yes. So, which is the correct option? Yes. A is going with 3, B is going with 1. C is going with 4 and D is going with 2. So, option 1 is your right answer. Yes, students, this is a knowledge-based question, students, and this is a knowledge-based questions beginning from the school level up to your entrance for the NEET. Okay, the next question reads that chlorine shows the bleaching action in the presence of moisture due to the formation of what? We know that chlorine is used as a bleaching agent. Yes, but it is used as a bleaching action in the presence of moisture, in the presence of water, due to the formation of which of the following choices? Is it hydrogen peroxide or is it nascent oxygen, option 3, or is it HOCl? Let us see that the reaction for the same, students. The reaction for the same is chlorine reacts with water to form HCl plus HClO. So, most of you will mark HOCl. Most of you will mark option 4, but that's not the correct option, students. We know that HClO, this HClO, students, will decompose to HCl and nascent oxygen. And it is the nascent oxygen which is used as a strong oxidizing agent over here. Okay, nascent oxygen brings about the bleaching action over here. Okay, the bleaching action is brought about by the nascent oxygen over here and not your HClO. So option 3 is the right answer, students. I hope most of you have marked the correct option. The next question is an organic chemistry question, students. You can see that. It says that the product formed in the following reaction sequence is. Okay, you're starting with an alkene. This 1-butene is made to react with HBr in the presence of benzoyl peroxide. When an alkene is treated with HBr in the presence of a peroxide, it will undergo anti-Markovnikov's rule of addition. That's the first step you have to keep in mind, students. So let us see the reaction for the same students. Okay, but1ene, CH3, CH2, CH double bond, CH2. When it is treated with HBr in the presence of peroxide, you know that anti-Markovnikov's rule is followed. According to anti-Markovnikov's rule, okay, bromine will get added to the CH2, H will get added to CH. You will get 1 bromobutane as the product. One bromobutane. Okay. Next, second step, it says it undergoes reaction with alcoholic KOH. You know that alcoholic KOH brings about elimination. When treated with alcoholic KOH, HBr is removed. If bromine goes from carbon number 1, hydrogen goes from carbon number 2, again the double bond will be formed between the first and the second carbon. HBr is removed over here. Yes, so you will get CH3, CH2, CH double bond, CH2. Get back the starting compound. And which is the option, students? Yes, it is option 2, which is the right answer. Okay, simple question, a very simple question of your 11th standard organic chemistry hydrocarbon chapter, students. Yes, it's a very simple question, straightforward. Okay, this is a very basic and a fundamental question. I hope most of you might have got this correct answer. The next question is a question where you have the 3 cells with their standard electrode potential of the cell given to you. Okay, 3 cells are given to you. The representation of the cells are given to you and their E0 cell in volts is given to you. This is a question of your 12th standard electrochemistry, students, right? Now, this question says that the standard Gibbs free energy change values for the 3 cells are respectively. That means you have to find out delta G0 for the 3 cells. Okay, E0 cell is given to you. Now, what is the relation between delta G0 and E0 of the cell? You know that's a very simple, straightforward relationship. Yes, students, what is the relationship over here? We know that the relationship is, the formula is delta G0 is equal to minus NF E0 cell. N corresponds to the total number of electrons lost and gained during the process. Yes, F is constant. F is your Faraday's constant, which is kept constant in the answer also, students. So you have to find out number of electrons for each representation. You can do this orally also, students. And I want you to do it orally because you don't have time for calculations. You can do this orally itself. Try to solve such questions orally if they are formula based. In the first cell representation, if you see that Fe is getting converted to Fe plus 2, that means there is loss of 2 electrons. And Fe plus 3 is getting converted to Fe, that means there is how many electrons? Yes, Fe plus 3 is getting converted to Fe, that means there is a gain of 3 electrons. Electrons lost is 2, gained is 3. So if you balance the number of electrons lost and gained, it becomes 6. Therefore, N value in the first choice will be what? If I consider in A cell representation, that is delta G0 will be equal to minus 6 into F into E0. E0 of the cell is given to you 0.404. When you multiply this, students, the answer should come as minus 2.424. Minus 2.424 F, because F is there. Similarly, you can do for option B. In option B, number of electrons lost and gained will be how much? Fe is going to Fe plus 2. That means number of electrons lost is 2. Then Fe plus 3 is getting converted to Fe plus 2. Number of electrons gained is 1. So lost is 2, gained is 1. So number of electrons lost and gained will be total 2. So N will be here what? Delta G0 is equal to minus 2 into F. E0 of cell is 1.2 1, 1. So when you do the calculation, delta G naught for this will also be equal to minus 2.424 F. 1.211 into 2 will give you minus 2.424 F. And you can verify for the third cell representation also. For C, Fe is going to Fe plus 3. Let's find out the number of electrons. Number of electrons going from Fe to Fe plus 3 is 3 electrons are lost. But Fe plus 3 is getting converted to Fe plus 2. Number of electrons gained is 1. Lost is 3, gained is 1. So when you multiply, the total number of electrons lost and gained will be 3. So N will be 3 over here. So delta G naught is equal to minus NF E naught cell. That is minus 3 into F into E naught cell is 0.807. Yes, students, when you multiply this also, you should get as minus 2.421 F. So you can see that A, B, C delta G naught value is coming to be same, and there is only one option in which the delta G naught values for A, B, C representation is the same, and which is that? Option 3. So option 3 is your correct option. This has been proved by calculation. Simple formula based question. Okay, you just have to apply it and find out the number of electrons. That's the basic thing which you are supposed to do. And if you are good in that, then definitely you should get full marks for this question. The next question says that the increasing order of reactivity of the following compounds towards acid catalyzed dehydration is. Acid catalyzed dehydration of the alcohols are given to you. You have to find out the increasing order of the reactivity. When you talk about the concept, you know that tertiary alcohols are more reactive than secondary alcohols. Secondary alcohols are more reactive than primary alcohols. Now look at the choices, students. In choice A, you have a primary alcohol. Yes. In choice B, you have a secondary alcohol, but that is attached to an cyclic compound with an unsaturation over there. That OH group is attached to an sp2 hybridized carbon atom. So the carbocation formed over there will be highly unstable, right? So if you remove the OH, the carbocation formed over there is highly unstable. Therefore, its reactivity will be the less. Least reactivity will be shown by choice B. Option C is a secondary alcohol. Its reactivity is greater than primary alcohol. And option D is a tertiary alcohol. It's a tertiary alcohol. So tertiary alcohols are more reactive than secondary alcohols towards dehydration, acid catalyzed dehydration. And secondary are more reactive than primary. So we can say that B is the least, then A, then C, and then D. So which is the correct option? So B is less than A, proved. Yes. Then A is less than C and C is less than D. B, I told you that because of the carbocation at the sp2 hybridized carbon atom is highly unstable after the OH is removed. Therefore, its reactivity towards dehydration will be the least. So B is less than A. A is a primary alcohol. Compared to secondary and tertiary, it is less reactive. Then is C, which is a secondary alcohol. And then is D, which is a tertiary alcohol. So option 1 is the right answer. The next question, number 85. It says that the chain length of silicones can be controlled by adding. Which of the following choices you will consider to control the chain length of silicones? Which one of the following choices on adding will control the chain length of silicones? Yes, the chain length of silicones can be controlled by adding. Option 3. Why? Suppose you have, let me explain the reaction. That is, you have an alkyl free radical. When you are adding this compound, that is CH3 thrice SiCl, what you are going to get? You are going to get is CH3 thrice SiR and Cl free radical. Now you can see that the silicon on both the sides is separated by alkyl groups. That means the termination stops over here. Okay, the chain length of silicons can be controlled over here. Yes, and Then what happens finally? The chloride free radicals that are formed will combine together to form Cl2. This is the final step. So we can conclude that, students, that this question, the correct option is option 3. CH3 thrice SiCl. So option 3 is the correct option.
Alright, so now let's discuss question 86. What it says. So it says that the major products which are formed in the following reaction. So as you can clearly see, this is an ether and it is reacting with Hi. Now we'll keep this point in our mind that whenever we have this kind of group, which is a tertiary alkyl group, we usually get 3-degree alkyl halide as my major product along with alcohol. Now since nothing is mentioned in this question, we'll assume that this Hi which is being present here, it's not excess. Let's say it's one equivalent only. If you have this doubt that there could be Hi in excess, then you can see the options. You won't find the need to assume that Hi is in excess. So we have to keep in mind it's one equivalent only. Now this is a question of alcohol, phenol and ether. As I said that since 3-degree alkyl halide is formed, you will break this particular polar bond like this in order to form a stable carbocation. Now this is a stable carbocation, and if I break similarly Hi, this is positive, this is negative. So where will you attach the I minus? We'll attach the I minus to this particular 3-degree carbocation. And thus the product which will be obtained by us will be CH3, 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 and it is connected with iodine plus. H plus gets connected with this particular CH3O minus, so we'll be getting methanol as the side product along with this 3-degree alkyl halide as my answer. If we go by mechanism, then how will we proceed? So if we go by mechanism, we'll keep in mind that we have CH3, CH3, CH3. This is your particular compound. What happens is, this is having oxygen and oxygen contains lone pair. Now when we'll make it react with Hi, so it will first attack the H plus. When it attacks the H plus, what happens? So oxygen will get a positive charge over it. So we'll be getting CH3, 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 O positive with a hydrogen attached to it and CH3. Right? Now in step 2, which is your slow step, we'll be getting carbocation as our intermediate. So what we'll be getting? CH3, 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 OH positive. We obviously know that oxygen with a positive charge is not stable enough. So H. So what will happen here? So in our next step, what will happen now? We'll be getting, in this slow step, carbocation formation. So we'll be getting CH3, CH3, CH3 like this. So we'll be getting this particular carbocation formation here. Along with that, you will be getting CH3OH as the side product. Now in the last step, after you have got this 3-degree carbocation, what will happen in the last step? We have CH3, CH3, CH3 with a positive charge over it. Now I minus will connect with it to give us a 3-degree alkyl halide. That's it. So this is your product, which is your main product, along with methanol as your side product. So if you'll see the options, you will realize here that option number 2 is your answer. Reason again, stable carbocation was the reason why we broke this polar bond to get the 3-degree alkyl halide. Let's talk about question number 87. Now this question is from the chapter Environmental Chemistry class 11th. It says that a student collected samples from 2 water bodies. A student collected samples from 2 water bodies, A and B, in a metro city. Now, the biochemical oxygen demand in city A is 3 ppm, they are saying, and in B it is 18 ppm. So, they are saying which of the following is true. So, it's a direct question. So, they are saying Both A and B are polluted cities. A is clean, B is polluted. A is polluted, B is clean, and the last option is both A and B are clean. Now, as per the NCERT, we know the statement that if your BOD, which is biochemical oxygen demand, which gives an idea that how much oxygen you need to break down the organic matter which is present in your water, or you can say that BOD gives an idea how much organic matter is there inside your water. So that much oxygen you need to break it, right? So if there is more amount of waste, you need more oxygen. That means there is more polluted water there. So we can say if your BOD is less than 5 ppm, we say your water is clean. But in case the BOD level is greater than equals to 17 ppm, we say such a water is highly polluted. So it is highly polluted. Right? So based on that, we can clearly say that 3 ppm lies within 5 ppm. So we can say that A is clean, whereas B is polluted. So your answer will be second. Our answer will be second for question 87. Now let's talk about question 88, which is a question from chemical equilibrium being asked, a part of physical chemistry. It says that consider the following reaction which is taking place in a 1 liter capacity beaker, and it is happening at 300 Kelvin. So it's happening at 300 Kelvin. A plus B gives C plus D. It's a equilibrium reaction, or it's a reversible reaction. It says that initially we are taking 1 mole of both A and B, and at equilibrium 0.7 mole of C is formed. So 0.7 mole of C is formed. They're asking calculate the equilibrium constant for this reaction. So temperature is fixed and we know how we calculate the Kc. So let's write the reaction. So the reaction is A plus B gives C plus D. So at time 0, how many moles are mentioned? It's 1 mole which is mentioned of each A and B. So we'll mention 1 mole of A, 1 mole of B, and initially C and D were not present as the products. As the time passed and the reaction reached equilibrium, what happened? So at time T equilibrium, we'll say some amount of A is lost, some amount of B is also lost, that is X according to stoichiometry, and X moles of C is formed and X moles of D is formed. Now the question has already mentioned that at equilibrium 0.7 moles of C is formed. That means this X value is 0.7. If X is 0.7 means this X is also 0.7 D moles. That means A moles at equilibrium will be 1 minus 0.7, that is 0.3, and 1 minus 0.7 again will give you moles of B. So we got the moles of each reactant and product at equilibrium. Now we just have to put the concentrations in the Kc expression, but for that we need to divide our moles by volume, and the volume which is mentioned is 1 liter. So we can clearly say that Kc is nothing but concentration of C raised to the power 1, concentration of D raised to the power 1, upon concentration of A raised to the power 1, concentration of B raised to the power 1. What is concentration? It's mole by volume. We know that when I do mole by volume to get my concentration, I will get moles only because volume mentioned is 1 liter. So let's put the moles itself then. So if I put the values, I'm getting 0.7, 0.7, 0.3 and 0.3. So it will give me 49 by 9, which gives me approximate answer of 9 into 5, that is 45. Again, you have this 40 going back. So 5.4 is my Kc value which I'm getting for this particular question. And that is why I will say that my answer is third. So this is the answer for this question. Talking about question number 89, which is a part of your class 12th physical chemistry chapter, which is electrochemistry. So what it says that the molar conductivity at infinite dilution is for NaCl, HCl and sodium acetate given as 126.4, 425.9 and 91.05 Simon centimeter square per mole. This is mentioned, 3 values. Now they are saying that if conductivity of this much concentration of acetic acid is 4.95 into 10 raised to the power minus 5 Simon centimeter inverse, then what is the value of alpha of acetic acid? Now, the simple thing we'll keep in mind is we know that alpha is nothing but it is lambda m, that is molar conductivity at any concentration C upon lambda m at infinite dilution. Now, we need both of these things to get to the alpha value. Now, first, let's talk about lambda m. How we calculate that? We calculate it by the formula conductivity into 1000 by molarity. See, it's a calculation based question. We can attempt it in the last as well, but it is something which is a formula based question only. So we can get a rough idea about the answer. You can take the help of options as well. They are not very close to each other. Okay. Now, conductivity value, what it is mentioned, it is 4.95 into 10 raised to the power minus 5 into 1000 upon molarity value, which is 0.00102. Now, the answer which you'll get approximately is 48.15. This is the value you get for molar conductivity at any concentration C. Now, let's talk about the molar conductivity at infinite dilution. So, at infinite dilution, if you'll calculate, the purpose is that we'll be using this Kohlrausch law. So how we calculate? We'll be saying that it is nothing but it is the summation of the molar conductivity at infinite dilution of sodium acetate plus molar conductivity at infinite dilution of HCl minus molar conductivity at infinite dilution of NaCl. Why I have subtracted NaCl part? Because neither I need Na nor I need Cl ions in my molar conductivity at infinite dilution of acetic acid. So, 1 plus 2 minus 3, it's like that. Salt plus HCl minus NaCl salt. Now, let's put the values. If I put the values for sodium acetate, it is mentioned as 91.05. For HCl, it is mentioned as 425.9. And for NaCl, it is mentioned as 126.4. If we'll calculate this particular, addition and subtraction, what we'll be getting is 390.55 Simon centimeter square mole inverse as my molar conductivity at infinite dilution, which has to be more than the molar conductivity at any concentration. And now finally I can say that alpha is nothing but lambda m upon lambda m infinite. Putting the values, if I put the values, so even if you find the calculation difficult, you can take the help of the options and you will realize that 48 by 390 it is roughly, right? And it is not just exactly 1/10, it is greater than 1/10, because if it's 339, then it is 1 by 10, right? So we'll search out for any option which is greater than 0.1. So is there any option greater than 0.1? So we have this particular option which is greater than 0.1. So we'll be saying that our answer is 2, which is 0.1233. Talking about question number 90. Now this question is from the chapter Hydrocarbons from alkyne section. Or we can say this is a question from your aldehyde ketone carboxylic acid chapter, but the preparation side. So you can link it to class 11th or you can link it to class 12th question. It says that the compound obtained by addition of water to an alkyne having more than 2 carbon in presence of mercuric sulfate and dilute sulfuric acid at 333 Kelvin. So see, they're not talking about an alkyne which is of 2 carbon, which we say as ethyne. They are talking about any alkyne who is greater than 2 carbon, that is greater than ethyne, right? So they are simply talking about addition of water to alkyne, means they're talking about hydration of alkyne, means we are providing water to our alkyne, and usually if we follow the Markovnikov rule only to understand the things in an easier fashion. So what we'll keep in mind that if I take an alkyne of carbon greater than 2, I'm taking propyne. So if I take propyne, which is CH3 C triple bond CH, this is my propyne. Now if I am treating it with water but in presence of mercuric ion and sulfuric acids H plus, so as I told you, it follows Markovnikov rule when we add H and when we add the OH, okay? So if I break this particular bond, I know that the OH part of water, according to Markovnikov's rule, will go to a more hindered carbon. So what will happen? We'll be getting our answer as CH3, C, OH, double bond, CH, and this H will connect here. So what we get here is a unsaturated alcohol. So in Tautomerism also we study keto-enol. So it's like that enol which we have got. Mercuric ion is also having its importance because water we are adding to alkyne. Alkyne is itself electron rich and water is also nucleophile. So when a nucleophile wants to come to an electron rich alkyne, we need to, lower down the electron density of alkyne. For that reason, we use these so as to help this reaction to carry out. That's why we use this heavy metal ion which is mercury. But when I talk about how to attempt this question, I said we'll use the Markovnikov's rule to add the water. So we have added the water and we have got this enol formation. Now, will I leave the answer like this? No, you don't have to. You have to try to make it more stable, and that's why we'll do the isomerism part in the last step, that is tautomerism. So what we have got so far is CH3, COH, double bond CH2. Now once we get this enol formation, we'll do the tautomerization step in which hydrogen is doing this 1,3 shifting. So hydrogen or this proton will do the 1,3 shifting. H plus will get connected here now. And how it looks now. So what we did is tautomerism. And the answer which we get here is CH3, C double bond O, single bond CH3. Because now the hydrogen has occupied this particular place. So this what we have got is keto format. And keto is more stable than enol in general because carbon-oxygen bond is quite stable. Carbon double bond oxygen. So this is our answer which we call as the propane 2-one. But for this question, they're not asking this specific product. They're just talking about what products we obtain. So we obtain ketone. Aldehyde we only get when we take a 2-membered alkyne, which is ethyne. Otherwise, it will be always ketone. And these are just to confuse you because alcohol was also formed in the very first step when we did the hydration, that is enol. But you don't have to leave it like this. So our answer for question number 90 is third. Talking about question number 91 now. Now question 91, what it says that given below are two statements. Statement 1, what it says that the Allingham diagram provides an idea about the feasibility of reaction. So now this is a statement based question. In NEET 2022, you saw statement based, you saw lots of match the column, which is actually an added benefit. Now this question is from metallurgy chapter. Right? General principle of isolation from class 12. So it's an inorganic question which is actually easy, which says that the Allingham diagram provides an idea about feasibility. Yes. Feasibility means how much this reaction is favorable, whether this reduction of oxide is favorable or not. So that is the idea which we get from the delta G value, because the graph of Allingham diagram is between Gibbs free energy and between temperature. So yes, it gives an idea about how much the reaction is favorable, thermally favorable. Now, statement 2 says that Ellingham explains the rate of the reduction reaction. Now see, it gives an idea about the thermodynamic feasibility, but it has nothing to do with the kinetics of the reaction. And therefore, statement 2 is wrong, statement 1 only is right. So it's a direct question. This statement is right, this statement is wrong. So we can say that statement 1 is correct, but statement 2 is incorrect. And there is no such statement which is confusing that, statement 2 is the correct reason for statement 1. No such question of that sort was asked. So it's a direct question. So your answer for question 91 is 4th. Talking about question 92. Now this question is from Aldehyde Ketone chapter, which talks about the oxidation of ketone. So it says that the product which is formed from the following reaction. So we are provided with a symmetrical ketone here. It undergoes oxidation under vigorous condition of high temperature and using a strong oxidizing agent CrO3 in presence of sulfuric acid. Now, you are provided with all the options which are actually acids. So what we get is actually mixture of acids in this case because of bond cleavage. Now, which bond breaks? So we keep in mind that the symmetrical ketone which is provided is RCH2, C double bond O, CH2R. Now the bond which breaks, if I number it as carbon 1, carbon 2, carbon 3. So either this bond will break or either this bond will break, which is next to the functional group. Now, since it's a symmetrical ketone, whichever bond I break, I'll be getting the same answer. So, if I break this particular C1-C2 bond, and then if I make the acids in this presence of strong oxidizing agent, on C1-C2 cleavage, if I do vigorous oxidation, from this side, the acid which I get is smaller in size, that is RCOOH. And from this side, the acid which I get will be of larger size, that will be RCH2COOH. Now, R could be anything. If R is symmetrical here, in fact, this question becomes easy. If R is not symmetrical, then we'll have to check. If R is not symmetrical and if it is RCH2COCH2R dash, then you have to break this bond or this bond, then you have to be careful depending upon the size, which side the alkyl group is of higher size. So we usually say that if this size is higher than this, then we'll say that the bond cleavage which happens will be like this, because CO goes with that particular side which is smaller in size, a smaller chain or a smaller alkyl group. But that is the case when my alkyl groups are different. Otherwise, here for a symmetrical ketone, whether I break C1-C2 or I break C2-C3, I'm getting the acid which is RCOOH from this side, and from this side the acid which I get is RCH2COOH. So the answer which I'm getting from here is third option. Mixture of acid is what we get when oxidation of ketone happens. This is your answer, third, for question number 92. Now question number 93, what it says? Question 93 says that for the given pair of lanthanoids, so you have been provided with the lanthanoid pairs, we have to identify that pair which is having one strong oxidant and one strong reductant, means a strong oxidizing agent and a strong reducing agent. Now we can clearly see in the options that cerium is in +4, so it wants to go to its common oxidation state +3, and europium is in 2 oxidation state and it will also try to go to its common oxidation state of lanthanoid, which is 3. We'll keep in mind, in fact, that cerium is having a very high standard reduction potential to convert from cerium +4 to cerium +3, which is 1.74 voltage, quite positive, right? So if you have so much high value of positive electrode potential, that is reduction potential, that means you want to reduce yourself and oxidize others. So cerium here is an oxidant, and europium, again, you can see the configuration also. Europium is xenon. Since it's 63, it is 6s2 4F7. So it's 54 plus 2, 56, 56 plus 7, that is your 63. So this is the oxidation state. If I talk about in plus 2, then 6s2 will become 6s0. And if I talk about the configuration of cerium, which is 58, it is xenon, 4f1, 5d1, 6s2. This is the configuration. If you remove all the 4 electrons, it is cerium in plus 4 state, and that is what is mentioned here. So it tries to go to plus 3, that is, it is reducing self and oxidizing others, and europium is actually oxidizing itself and reduces others. So these are the strong oxidants and strong reducing agent. Your answer is 3 for question number 93. Let's talk about question 94. It is related to your chapter, which is atomic structure, and it says that a monochromatic infrared rangefinder of power 1 milliwatt emits photons with wavelength 1000 nanometer in 0.1 second. So the number of photons emitted in 0.1 second is, this is the question. Now, so many values are given for you, that is for Planck's constant, for speed of light. Now, we'll keep in mind to solve such a question, we'll keep in mind that the total energy is equals to number of photons into energy emitted by one photon, which is h nu, where h mu, in this we have mu as the frequency. So energy is what? Energy is power into time. N we need to calculate as a number of photons. H is Planck's constant. Frequency can be written as c by lambda. So hc by lambda is the energy of one photon. Now if I put the values, my power which is given is 1 milliwatt. So if I make it in watt, it is 1 into 10 raised to the power minus 3 watt now. Time is given how much? 0.1 second. H value is 6 point, what value is given? 6.626 into 10 raised to the power minus 34. Speed of light is 3 into 10 raised to the power 8. And the lambda value which is given is 1000 nanometer. 1000 nanometer is 10 raised to the power minus 6 meter, because this is also in meter per second. So it also has to be in meter. Now if I calculate the n value, and I take these things here, so it will be 10 raised to the power minus 3 into 0.1 into 10 raised to the power minus 6 divided by 3 into 6.626. Taking 10 raised to the power minus 34 this side, it becomes 10 raised to the power plus 34, and it becomes 10 raised to the power minus 8. So n value, if I calculate from here, if I'll see all the powers, it is 10 raised to the power minus 4, this is 10 raised to the power minus 10, and this becomes 10 raised to the power minus 18. 10 raised to the power minus 18 and 10 raised to the power 34. So it becomes 10 raised to the power 16 upon 3 into 6.626. If I take out 100 from this power, so it becomes 10 raised to the power 14, and then we can solve this question. So you can see clearly it is around 20 in the denominator. So your answer will be around 5 into 10 raised to the power 14. And this much number of photons are actually being emitted. So where is your option? Your option is 5 into 10 to the power 14 photons are emitted. So your answer is 1 for this question 94. Now talking about question 95, it is a IUPAC naming question which says that the correct IUPAC name of the given compound is. Now we need to number from the side which is having ketone, because it's a function group. So we'll be saying 1, 2, 3, 4, 5 and 6. So at number 4, we are having this substituent which is methyl. So how we'll be naming it? So we'll be saying it is 4-methyl. And then in continuation, we'll be saying that the parent chain is of 6 carbons. So 4-methyl hex. Then at position 3, we have a alkene. We'll stop here. We'll not say ENE. And then the position of ketone, which is 2, and then on. So your answer for this question is first 4-methyl hex 3-ene 2-on for this question 95. Okay, coming to question 96. This question is regarding the total pressure which you need to find out. It's related to states of matter, which says that at 300 Kelvin, 250 ml of gas A at 1 bar pressure is mixed with 500 ml of gas B at 2 bar pressure in 1 liter flask. Now, they're saying gas A is not reacting with gas B and we have to tell the final pressure of the mixture. So, we have gas A, we have gas B, we are mixing them. When we mix them, that doesn't mean that the moles of A and B will change. So, we can say that the moles net is equals to moles of A plus moles of B. And we have to assume here that the gases which are taken are ideal gases. So, we can use this concept PV equals to nRT. And I can say that moles is PV by RT. If I put this in my main expression of mole conservation, I'll be getting pressure net, volume net by RT is equals to PA VA by RT plus PB VB by RT. Now, if I solve the P net, I'll be getting pressure net is coming PA VA plus PB VB by total volume. Putting the values, I'll be getting pressure for the first is 1 bar, volume is 250 ml. Pressure for the second gas is 2 bar, volume is 500 ml. Total volume is 1000 ml after we have mixed it. On solving, we are getting 1250 upon 1000, which gives us 1.25 bar as my net pressure of this mixture. So, our answer for this question is third for question 96. Question 97 is based on the chapter amines, and this question is having 2-3 things asked together. Now, we have nitrobenzene. First, it is undergoing reduction. Then, it is undergoing this process in which it is being made to treat with acetic anhydride. Then, we are trying to carry out the bromination process and then ultimately hydrolysis. 4 things are asked here. So, they're asking us the major product here. We'll keep in mind on reduction of nitrobenzene, with SnHCl. What we get is aniline. Now, this aniline is being made to treat with acetic anhydride, which is CH3CO whole twice O, and that is in presence of a base which is pyridine. Now, when we do so, we are actually forming a compound from aniline which is acetanilide. So, this is NHCOCH3. So, we get this compound which is acetanilide. Now, once we get this compound, we have tried to reduce the activity of aniline by this process. In the next step, what we do is now bromination. So, when we do the bromination process, that is Br2 in presence of acetic acid, we can get the bromine either at ortho or at para, because this is the ortho-para directing group. So, we can get either at ortho position or at para. Since para is less hindered, so bromination preferably will happen there, and that will lead to my major product. So, it will be bromine at para position, and we are getting this as NHCOCH3. And finally, in the last step, we are undergoing the hydrolysis process, where we are breaking this and we are providing it hydrogen, and this side we are providing it OH of the water in basic medium or in acidic medium. So, right now it's given basic medium. So, finally what we get is aniline, bromine, and what part goes away as byproduct is acetic acid, which is CH3COOH. So, this is your answer, and that is why this particular question is having answer as third. Talking about question 98. Now, this question is from coordination compounds, which says that which of the following is the correct order of spin-only magnetic moment for the given complexes. Now, we'll keep in mind here that we need to take into account that our ligands are weak field ligands or strong field ligands. So, we can clearly see here that cyanide is a strong field ligand, whereas water and chlorine, these are weak field ligands. Now, keeping that thing in mind, strong field ligands favor pairing. So, we'll keep that into account. Now, in these options, we have iron, cobalt and manganese as the central atoms. Now, what's their oxidation state? So, iron is having oxidation state +3. Cobalt is having oxidation state +2. And manganese is having oxidation state +3. So, these are the respective oxidation states which is mentioned for all these compounds out here. Now, what we'll see is, what is the configuration of iron? So, let's talk about iron configuration first. Iron in oxidation state which is +3, it is argon 4s0 3d5. Now, 3d5 looks like this. But because of pairing by cyanide, now the number of unpaired electrons it will possess will be 1 only. So, its spin only magnetic moment will also come less. Now, talking about the next central atom which is cobalt in +2. So, cobalt in +2 is how much? Argon. Cobalt is 4s2, 3d7. So, after we remove 2 electrons, it is 3d7, 4s0. So, how many unpaired electrons it possesses? 1, 2, 3, 4, 5, 6, 7. This is how it looks. So, since no pairing will happen because water is a weak field ligand, so number of unpaired electrons which we have is 3. And finally, for manganese. Now, manganese, if I talk about, here its oxidation state is +3. So, it will be argon 4s2 3d5. This is what we have. So, we'll be saying it is 4s0 3d4 now, right? So, if I talk in that regard, this is the number of electrons it is left with now, right? So, 1, 2, 3, 4, this is actually the number of unpaired electrons because chlorine is a weak field ligand. So, N value will be 4. And thus, I can say that the spin only magnetic moment will be maximum for manganese complex, then for cobalt complex, then for iron complex. So, what I can say is that my answer will be third. For manganese complex, we say that manganese is having unpaired electrons 4, then cobalt is having unpaired electrons, how many? 3, and then iron is having 1 only as the unpaired electron in presence of cyanide. So, answer for this question 98 is third. Talking about question 99. Now, this question says that which statement among the following is not correct? Now, this is a solid state question. Ferrimagnetism arises due to the alignment of magnetic moments of the domains in the substance in parallel and anti-parallel direction in unequal number. Yes, we know that in ferrimagnetism, if some domains are aligned like this, some will be aligned like this, such that they don't cancel out each other completely. So, this is a right statement. And they are asking us not correct. Then replacing some silicon by boron gives a p-type semiconductor. Yes, absolutely. Replacing some germanium by group 15 elements, that is phosphorus, will give us n-type semiconductor. Yes, absolutely. And thus the odd one out is fourth only. So this is your incorrect statement which says conduction band and valence band overlap in semiconductor. No, they don't overlap. They are at a small gap from each other. They don't overlap like it happens in conductors. So, our answer for this question will be fourth for question 99. Okay, coming to a last question, which is question number 100. Now, let's talk about this particular question, which is question 100, which says that the plot of ln K, where K is your rate constant, versus 1 by temperature, they're talking about that for this reaction, if we plot a graph between ln K and 1 by temperature, my slope value is -1 into 10 raised to power 4, and they're asking us the activation energy. Now, we know very well that the Arrhenius equation in terms of log is ln K is equals to ln A minus EA by RT. Now, if I compare it to y equals to C plus mx, I can clearly say from here that this part is my slope. So, if I compare these two, I'll be getting minus EA by R, which is my slope, that is minus 1 into 10 raised to the power 4. Minus minus will get cancelled. R value, if I take this side, it is how much R value? 8.3 into 10 raised to the power 4. So this is my activation energy actually by using this log or this natural log version of Arrhenius equation. So our answer is third for question 100. So we can clearly understand that when I talk about this chemistry paper, it was a balanced paper having around 17 questions from physical chemistry, 16 from inorganic, and around 17 questions being asked from organic chemistry. So it was quite a balanced paper which is having around 25 questions from class 11th, around 25 questions from class 12th. And you have this benefit of 5 questions as optional as well. So it was a balanced or a moderate paper of chemistry. If you have read the questions properly, if you have this proper time management, surely you can score good. So that's the analysis of chemistry from our side. Thank you.